everyone, my name is Rakshita. I'm pursuing my degree from Sri Venkateswara College of Engineering from the Department of Electronics and Communication Engineering, final year. Today I'm back with another video. Today in this video I'll be discussing about the subject called computer network. In this subject I'll be discussing about a topic called OSI reference model and TCP model. So without any further delay, let's begin into the video now. The OSI model, created in 1984 by iOS, is a reference framework that explains the process of transmitting data between computers. It is divided into 7 layers that work together to carry out specialized network functions, allowing for a more systematic approach to networking. The main concept of OSI is that the process of communication between two endpoints in a network can be divided into 7 distinct groups of related functions or layers. Each communicating user or program is on a device that can provide the 7 layers of function. So this is the 7 layer of the OSI model. The first layer is the physical layer. The second is the data link. The third is the network layer. The fourth is the transport layer. The fifth is the session layer. Sixth is representation layer. And the last layer, that is the seventh layer, is application layer. This is the client side and this is the server side. So now let's discuss about the layer one by one. The first layer is physical layer. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. The physical layer contains information in the form of bits. It is responsible for transmitting individual bits from one node to the next. When receiving data, this layer will get the signal received and convert into zeros and ones and send them to the data link layer, which will put the framework together. Here, these are the steps involved in the physical layer. The first is the bit synchronization. The second is the bit rate control. The third is the physical topologies. And the last one is the transmission load. So, bit synchronization. In bit synchronization, the physical layer provides the synchronization of the bits by providing a clock. This clock controls both sender and receiver, thus providing synchronization at the bit level. Next one is the bit rate control. The physical layer also defines the transmission rate, that is the number of bits sent per second. Next one is the physical topologies. Physical layer specifies how the different devices are arranged in the network, like bus, star or mesh topology. The third one is the transmission mode. Physical layer also defines how the data flows between the two connected devices. The various transmission modes possible are simplex, half duplex and full duplex. The next one is the second layer, that is the data link layer. The data link layer is responsible for node-to-node delivery of message. The main function of this layer is to make sure data transfer is error-free from one node to another over the physical layer. When a packet arrives in a network, it is the responsibility of the DLL to transmit it to the host using its MAC address. In data link we have framing, physical addressing, error control, flow control and the access control. The first one is the framing. Framing is a function of the data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching special bit pattern to the beginning and the end of the frame. The next one is the physical addressing. After creating frames, the data link layer adds physical address of the sender and receiver in the header of each frame. Next one is the error control. The data link layer provides the mechanism of error control in which it detects and retransmits the damaged or lost frames. The next one is the flow control. The data rate must be constant on both sides, else the data may not be computed. Thus, flow control coordinates the amount of data that can be sent before receiving an acknowledgement. The next is the access control. When a single communication channel is shared by multiple devices, the MAC sublayer of the data link layer helps to determine which device has control over the channel at the given time. The third layer is network layer. The network layer works for the transmission of data from one host to the other located in different networks. It also takes care of packet routing, that is, selection of shortest path to transmit the packet from the number of routes available. The sender and receiver's IP address are placed in the header by the network layer. These are the steps. There are two steps involved in network layer. First one is the routing. The second one is the logical addressing. In routing, it determines which route is suitable for the source to destination. This function of the network layer is known as routing. And the next is the logical addressing. Here, to identify its device on internet work uniquely, the network layer defines an addressing scheme. The sender and receiver's IP addresses are placed in the header by the network layer, such as address distinguishes each device uniquely and universally. The next is the transport layer, that is the fourth layer. The transport layer provides the service to the application layer and takes service from the network layer. The data in the transport layer is referred to as segments. It is responsible for the end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of the successful data transmission and retransmits the data if an error is found. Here we have two steps: segmentation and reassembly. Here, service point addressing. First, let's see what is segmentation and reassembly. This layer accepts the message from the session layer and breaks the message into smaller units. Each of the units produce as a header associated with it. The transport layer at the destination station resembles the message. The next step is the service point addressing. To deliver the message to the correct process, the transport layer header includes a type of address called service point addresses or port address. Thus, by specifying this address, the transport layer makes sure that the message is delivered to the correct process. Now, let's see about the sixth layer, that is the presentation layer. The presentation layer is also called the translation layer. The data from the application layer is extracted here and manipulated as per the required format to transmit over the network. Here we have the three steps. First one is the translation, next one is the encryption and decryption, third one is the compression. Now let's see one by one. First, translation. It may be from ASCII to EBCID. Next one is the encryption and decryption. Data encryption translates the data into another form or code. A key value is used for encrypting as well as decrypting. Next one is the compression. Reduces the number of bits that need to be translated on the network. The last layer is the application layer, that is the layer 7. At the very top of the OSI reference model stack of layer, we find the application layer, which is implemented by network applications. These applications produce the data which has to be transferred over the network. This layer also serves as a window for the application services to access network and for displaying the received information to user. Here we have the following steps. First one is the network virtual terminal. Second one is the FTM, that is file transfer access and management. Third one is the mail service. The last one is the directory service. Now let's see one by one. First one, network virtual terminal. It allows user to log on the remote host. Next one is the FTAM. FTAM, file transfer access and management. This application allows to user access file in a remote host, retrieves file in the remote host, and manage or control file from a remote computer. Next one is in mail service, provide email services. Last one is the directory services. This application provides distributed database sources and access for global information about various objects and services. Now, let's discuss on TCP or IP suite model. The main work of TCP or IP is to transfer the data of a computer from one device to another. The main condition of this process is to make data reliable and accurate so that the receiver will not receive the same information which is sent by the sender. To ensure that each message reaches its final destination accurately, the TCP/IP model divides its data into packets and combines them at the other end, which helps in maintaining the accuracy of the data while transferring from one end to another. These are the various layers in the TCP or IP suite model. The first is the application layer, the second is the data link layer, third is the internet layer, fourth one is the transport layer, fifth one is the application layer. Now let's see in detail about one by one. The first is the physical layer. It is a group of applications requiring network communications. This layer is responsible for generating the data and requesting connections. It acts on behalf of the sender and the network access layer on the behalf of the receiver. During this article, we will be taking on behalf of the receiver. The next is the data link layer. The packets network protocol type, in this case TCP or IP, is identified by the data link layer. Error prevention and framing are also provided by the data link layer. The next one is the internet layer. This layer parallels the functions of OSI's network layer. It defines the protocols which are responsible for the logical transmission of data over the entire network. Next one is the transport layer. The TCP or IP transport layer protocols exchange data receipt acknowledgements and retransmit missing packets to ensure that packets arrive in order or without error. End-to-end communication is referred to as such. Transmission Control Protocol and User Datagram Protocol are transport layer protocols at this level. Next one is the application layer. This layer is analogous to the transport layer of the OSI model. It is responsible for communication and error-free delivery of the data. So thank you all for watching my video. Please to like the video, share and subscribe to my channel. Thank you all.